Georgi said, I am a PhD student at the University of Glasgow. I'm a final year, and I have spent the last 3 years of my life doing analyses in R and MATLAB. Unfortunately, I do prefer R, and programming a lot of things either in Python or in MATLAB or whatever other derivation there comes of. But specifically about R, I have used R for the past 4 years, which is when we got introduced to it. I did SPSS before that for my undergraduate, and in my master's here we were told, you're going to do advanced statistics now in R, here's a 3-day boot camp, and this is how I got introduced to it. And even though everybody hated it from the beginning, then we decided we can't live without it, and I haven't stopped using it since. And I think it's a great tool for academics and for statisticians, because in the end it is a statistical tool. And I'm hoping to convert at least one person from today to at least consider R as an option. There are at least 5% of people who use Python before that then go to R afterwards. There's research on it, I've checked. So R, from the ease of data wrangling through the beauty of plots to the joy of ShinyApps. I'm going to go quickly and cover all of these 3 topics, and hopefully I'll be able to sell R to you. So R was developed by statisticians and academics for statistician and academics, and in this way, it is in a statistical software. So it's best at dealing with data, manipulating data, doing statistical analysis for it, graphically presenting it, and modeling. So this is why it's so good for academics and researchers and students, for that matter, who don't have any computational or not computation, computer science education, because they don't tend to know specifically how to program. So when you tell a student specifically that they have to now write their own code in order to analyze their own data, it's much easier to try and introduce something that has a statistical logic in the way that the code is written than something that is a completely programming and developing tool, like things like Python and JavaScript, for example. So R has been gaining a lot of traction in the past couple of years. If we just look at Stack Overflow, which is the beautiful graph on the side here, we can see that R, if we exclude Python, JavaScript, Java, C#, and PHP, which are players that R shouldn't even be in the same playing field with, we can see that R has been gaining quite a bit of traction in terms of the number of questions and views per month, and this is only up until 2018. However, if you look at the, I'm going to go with TOP index for most popular programming language, you can see that R is in number 9 this June, where it was number 22 in June last year. And the popularity index here is calculated just based on how many times it was searched on any of the search engines. And it is an extremely useful language because there's so many people or so many academics using it that there are so many people asking and answering questions. So it's a massive community. And making it easy to read and follow syntax is what makes it so appealing to academia. So what is one of the best things about R? One of the best things is the amount of packages and functions and anything that you might need to do. Somebody has already done it and put it in a package, or that is already on CRAN, which is a package repository. Or if they haven't put it on CRAN, they've written it up, put it in a package, and put it in GitHub, and where you can go and download it. Or even if that's not there, there's a statistician down the hall or like the office next to you, which I have one of those in my department, that I can go and knock on the doors and ask them, I'm trying to do this, and they'll send me a text file with a bunch of R functions that I can use in my analysis. They're extremely easy to install. They're extremely easy to use. There is no pip, thank God, because I can't deal with pip. However, it doesn't matter where your package comes from. You're just installing it as anything else. You're installing a package and then you're loading it using library. And it's the same kind of code, regardless of whether it's you're downloading it from a CRAN or from GitHub. I'm going to be talking specifically about the tidyverse package, which was created by Hadley Wickham, and it introduces the tidy universe. It's a compilation package that combines a lot of packages that are there to help you manipulate data and make it into the format that you might need it afterwards to either create plots with it or do statistical analysis on it. Additionally, the package contains ggplot2, which is the package that creates wonderful plots, which are the biggest selling point of R when you try selling it to undergraduate students. So, how I'm going to introduce this to you, I decided that we can look at some of the Scottish Government data that they have at statistics.gov.scot. They have a vast majority of data files and open source documents that you can use and then analyze. It's data that is collected throughout the years, throughout different councils, different NHS health boards. So there's a lot of data there that you can do a lot of fun things with. So here I've decided to have a look at our Scottish people the mental health and the mental well-being of Scottish people changing throughout the years, and is that related to how far they live from a park or from the sea, so from a green or a blue space. So I've downloaded two datasets from the Scottish Government website that look exactly into that. Additionally, I have wrangled a dataset that is called the geo area here, that just contains the feature codes, which is the code of each of the councils or the NHS boards, etc. In this way, it will be able to give it not only a number, but also a name. So if you look at the data for the green and blue space proximity, we can see that it is a very nice table. You have all of the information and it is extremely complete. You have 95% upper and lower limits. You also have the percentage that is in the middle. You have how far the people live, so whether they live 5 minutes, 6 to 10 minutes, and 11 minutes or more away from their nearest green or blue space. You have it separated by age, by gender, type of tenure, household type, etc. However, this type of data set becomes a little bit too clunky to work with, although it has a lot of information. Just for the purposes of today, I'm going to reduce it down quite a bit. And I'm going to do that by wrangling it using tidyverse. So it is a nice looking data set. However, it has a lot of unnecessary information. And for those of you that know how to use pipes, and I'm sure most of you do, the idea is that you don't create a number of objects in your environment that start up wasting space and make, well, in our case, make R slightly slower in doing its computations. So the good thing about the tidyverse functions and the package as it is that all of the functions are there as in verbs inside of sentences. And then when you add in the pipe afterwards, you can read a whole chunk of code that analyzes your data in a way as of one very long paragraph. So if we look at the data set with the proximity to green and blue spaces, you can see here that this is quite a lot of code, but in reality, it gives us one extremely neat table at the end. And it's very easy to read in terms of what exactly I have done to this data set. So I have decided to pick the data set, which is green_blue, which is what I named it. And then I'm filtering in, so I'm keeping only the relevant rows that I care about. So I don't want to look at the data for males and females. I don't want to know what are the SIMD quantiles. I don't want to know what the urban-rural classification is. However, I do want to look at it based on age. Therefore, I don't want the compiled all. And I don't want to look at the 95 percentiles, and I just want to look at the percentage. And I also want to know how far exactly they lived from that green or blue space. So answers like I don't know are not really useful here. So in all of this, I have already reduced my data set quite a bit. I'm adding in our geo area data file that has the names of all of the councils by the variable that is common to both of the tables, and then I'm selecting only the variables that I really need, and then I am renaming the variable called value to something more meaningful, like percent of the population that lives X number of minutes away from their nearest green and blue space. So just by reading this, it makes it extremely easy to follow exactly the train of thought. And when we teach students in psychology, specifically on how to wrangle the data, how to make their data into a format that they can then use, it's easy to ask them to think about how they would do it step by step, and writing down all of these all of these steps, because then they can just follow them, because it's exactly the same language as you would use when you're trying to explain what you're going to do step by step. So from all of this, you end up with a very nice and neat presentation of a data table that gives us a lot less information. Of course, this is only the first three rows, but you can see that in South Ayrshire in 2014, there were 68% of 65-year-olds that lived 5 minutes walk or less away from a green or a blue space, which is great for all of those 65-year-old people. So data wrangling becomes extremely straightforward because more or less follows the same type of pattern, and it's very easy to get into. Once you get used to the name of the functions and how each function works, you can write basically paragraphs and paragraphs of code where you're wrangling your data into a format that you want to look at. And even if you look at the data that I've wrangled for the well-being of the Scottish population, we can see that it's exactly the same. I'm choosing the data set, I'm filtering the relevant information, I'm joining it with the names of the council areas, etc., etc. So we have all of this data. Now what do we do? Well, first of all, we want to plot it. And as I said, ggplot is a part of the tidyverse package, and it is an exciting addition to R because it makes wonderful plots. And as I said, this is the way that we try to sell R to students. Specifically, if you have done SPSS like I did in my undergraduate, you know that plots that are produced by SPSS are not the most beautiful plots in the world. So ggplot, along with all the wrangling that I just did, again follows this type of layering pattern where you add in on top of each other. So ggplot is always the first function, which starts off with, this is the type of data that I want to look at. In this case, I have said that I also want to look at specifically at the Glasgow City Council, the City of Edinburgh Council, and then the Highlands. And I'm specifying what is my X, what is my Y, and then everything from then onwards is just specifying what goes on top of the grid of the plot. So I'm saying that I want to plot my data. I want it to be colored based on how far people live. I want to separate it by age. So I want to have different small graphs for age or for and for where they lived. I want to create my themes appropriately. So I want to have a black and white theme, so I don't have to go and change the background and change the all of the labels specifically, but I can have something that is already there and then just add on top of it in specifying that I want my axis to be blue and my legend position to be on the top. And this is the same kind of pattern that you would do absolutely always when you're trying to make a plot. You're picking what you're plotting, you're saying what type of plot you want, and then everything else is just making it prettier and prettier. So how does this kind of plot look like? So this is the plot that the code that I just showed you, and this is the plot that I created for well-being. What we can see from here is that indeed it seems that there is some sort of difference between where people live and how old they are, and how far away they live from a green or blue space. However, you can also see that there doesn't seem to be much difference in general. A lot of people live very close to a green or blue space in comparison to fewer people that live further away. However, this is not the case for Glasgow. Potentially, this is because in Glasgow, it's a much more spread out city. Therefore, you have people that live further away from their nearest park or a river, whereas at the city of Edinburgh, which is a much smaller location, it's easier to live to something that is 5 minutes or less closer to you. On the other hand, we have the Highlands, which well, basically the Highlands is just a lot of green and a lot of blue. So it's very easy there to have about 80% of the population living near a green or blue place that's 5 minutes away. And if you look specifically at the well-being, we can see that the well-being does tend to differ based on where the people live. Specifically, Glasgow people seem to be a lot less, to have a lot less positive scores in terms of mental well-being, whereas in the Highlands, the variation does change depending on the age of the individuals. However, the general pattern does seem to be that with the progression of the years, regardless of age, you do tend to see some sort of decline in the mental well-being scores that people are giving. So we have some sort of an idea of how the data looks like. We have some sort of an idea of what kind of trend there is. So how do we progress from here? Well, as I said, R is a statistical software. It is there to help statisticians and academics do statistical analysis, which means that the outputs from statistical formulas and statistical analyses are going to be easily read. Yeah, easily read. So let's say we want to know whether Scottish people's mental well-being reduces throughout the years, and we want to know whether that change is significant, and we want to know whether living closer to the sea or not is related. Specifically, we want to know whether it's 5 minutes or less, because all the other ones are going to be additive to those 5 minutes or less. So if we remove the overall Scotland council or country in this case from the whole data set, and then we add in the data set from green and blue using an inner join function, which is similar to what we had in the addition of the names of the councils. We can then have a look at a simple linear regression of how the year and the percentage of the population that lived 5 minutes or less away from a green or blue space affected the well-being score of the individuals in Scotland. So if we have a look at the output is extremely straightforward. It tells us the spread of the residuals. It tells us the coefficients, which is something that you always want to know. You have your intercept, you have your beta values, you have your interactions here, and then you have all of your R squares and then adjusted R squares, etc. And you also have, of course, a p-value, which is how significant is your R squared. But what's more important here is to see that based on the data that we were looking at, we can tell that yes, throughout the years, individuals do tend to reduce the amount of happiness or mental well-being that they possess, or at least what they report. Something else that we noticed from the graphs before, from these graphs, is that there seems to be quite a bit of variation in terms of the well-being score based on where people live. And specifically, if you look at middle-aged adults, which are from 35 to 64 years of age, we can see that although in the cities there seems to be some sort of a reduction in terms of their mental well-being score, there seems to be an increase in the Highlands, whereas all the youngsters and the 65 years and over individuals do tend to show a similar pattern. So let's think about how we can look at that. We've plotted some plots, but if you have to look at absolutely every area and you have to create a plot for absolutely every area, that will become extremely cumbersome. And then if you have to do a statistical analysis on it, at this point, it might be underpowered because we wouldn't have that much data to work with. So let's make everything on top of a map so that we can visualize it. Sometimes visualizations are a lot more important in order to extrapolate what type of pattern might be going on. So there's a different package here that I'm going to use, which is similar to ggplot. However, instead of creating two-dimensional plots, it can create, well, it's also a two-dimensional plot, but it creates maps instead of histograms or scatter plots, etc. So we can get the data from the Scottish government. They have created a shapefile for the shape of Scotland and where each council is, and then we can join in our well-being data with it. As I said, we want to know specifically about the 35-year-olds to 64 years old. This is because we did see some sort of variation in them in the graph that we were looking at. And that's why we're going to only focus on them. So you can see that the syntax is pretty similar to ggplot. If I'm not mistaken, it was inspired by it. It's again using the layering system. So in the first layer, you have what is the shape, what is my data, Scott well-being, which is what we just created. And then you're basically saying what exactly do you want to plot? Well, I want to fill in all of the cancels with different areas based on the score that they got. I want to pick a specific style similar to the teams in ggplot, and then I want to have some sort of variation in terms of the width of the legend. And then the last line is what allows me to further make this map a lot more interesting. Is I'm saying that I want to look at the year very differently in terms of I want to look at it separately, but I also want to look at it in terms of an animation. I don't want to have 5 different plots one next to another. I want to see how it looks throughout time. And this is what tmap animation, which is an additional function with the tmap package that helps. And we can, if we look at the data, which is nicely plotted here with this nice GIF image, we can see that there definitely is something that 35 to 64-year-olds do tend to feel a lot happier throughout the years, especially if they start living in the Highlands or if they have been forever living in Highlands. Potentially, they've always thought that life was better in the city, and then they realized that their life is much better in the Highlands around all of the green and the fresh air. So this is how you would analyze a type of data set. You can see that it's extremely straightforward. It is very easy to be able to follow more or less the same type of steps until you reach your end result. Of course, you can do a lot more with R. You can do a lot of modeling, a lot of programming, a lot of, you can build something from the ground up if you're really keen to, but for the majority of the time for statistical analysis, from data manipulation, you wouldn't need to do that. So this is what makes packages like tidyverse and specifically R so good at it, because it's easy to teach academics that don't have any computer science education. And now I want to show off a different functionality of R, which is the creation of ShinyApps, which is the ability to create an app without knowing how to create applications in general. I have worked on several apps and I have never developed an app, for example, in Python or in anything else. It will probably take me a lot longer to learn how to do that, even though I do use MATLAB and Python, etc., on almost a regular basis. So here I'm going to show you exactly how it's done. It's all in one script or two, depending on the type of philosophy. You have some people do separate it, and sometimes if you have a very long app or a very big app, you do want to separate it because it becomes too long of a script. But for most occasions, you can do it either way. So let's have a look at a simple Shiny app, which was developed by RStudio. So this is the simple Shiny app. It is one file which has the user interface, which is one big function, which basically tells exactly what you see, what you would expect from a user interface part of an app. It tells us that we have a title panel, we have a sidebar panel. It tells us what we have in that sidebar panel. So we have radio buttons, and then we have the slider input, and then we have a main panel with all the 3 tabs. Additionally, after we've done setting and telling R exactly what we want our app to look like, we can then go on and create the discovery part of the app, which is describing exactly what happens basically at the backside of the application. So here we're saying that this part of the app is going to be reactive. So every time something switches in here, so the input from this, which comes from the radio buttons, because this is how it was named, this is going to create some sort of function, and then using the input from the number of observations from the slider, we're going to create a distribution. So that distribution is then going to be used into the output of the plot, which will create the plot on its own. It will also create a title, and it will also create the summary at the end, and then it will create the output table, which is at the third side. So if we have a look at how this looks like, let's say I want to create a exponential distribution, and I want to have 700 observations, you can see that it highlights exactly what I'm changing and what is being produced. If you go to summary, you'll be able to see that summary gets highlighted, so it's going to tell me exactly what the summary of that data set is, and then it will show me exactly the table. So this is an extremely straightforward way to make apps, and you can make a large amount of apps on different variety of maps. You can make almost anything into an app if you're keen to do so. So here I have suggested a couple of variations. So you can go from very simple apps, for example, the Scottish National Records and the Scottish government have an app where you can pick what your name is, and you can check how popular that name has been in Scotland for the past several decades. So for example, if I look for my own name and for a Carol and a Carol with a C, then we can see that after a while, we can see that there are at least 6 little girls that have been named Greta in 2019, where there haven't been any Carols, regardless which Carol with a C or Carol with a K, and whether it was male or female. So yay for me, or yay for my name. I'm being popular. Additionally, you can have things like an effect size calculator, which I'm not going to show off now, but you basically can just plug in whatever you want, and it's just something similar to this one. And you can have something a lot more complex. So for example, you can have a map of the UK's with data from Police UK, where it will be able to show you exactly the distribution of crime. So let's say we want to look at crime in Cambridge. And then it will be able to show us exactly the distribution of crime in Cambridge and the type of crime. So Cambridge has a lot of antisocial behavioural incidents, quite a bit of bicycle thefts, not that much burglary. If we look at Leeds, for example, then we'll be able to see that there's a lot more of violent crime in Leeds, and shoplifting and antisocial behaviour. So you can scroll around all of the data that there is available, and you can pick your own city and see what happens. Alternatively, you can go completely out and do whatever the Scottish government does, is to create massive dashboards that are used to present the Scottish government data and statistics. So in this case, I'm going to show you the Scottish Energy dashboard, which shows off how Scottish Energy is being used. Of course, it's going to take a while because it's an extremely heavy app, because it has a lot of things on it, and it can show quite a lot of things on it. But it tells us about Scottish Energy statistics. As I said, you can look at, for example, COVID-19. You can see the daily demand for electricity. You can see what it's like last week of this March in comparison to last week of March. So this is the first 3 weeks of March, whereas this is the last week of March and to the second week of June. So you can see that the beginning of March, there was a lot more electricity used in comparison to after the lockdown happened, for example. So I hope that I managed to convince you that R is fun, it's easy to use, specifically if you're working with data manipulation and with data visualization and analysis and its statistics specifically, because it makes things a lot easier just to write and to understand, and then to teach other people to do it, which is a lot of the stuff that we do in academia. However, if you need a little bit more convincing, there is the joy of RStudio, which is the IDE for R. It allows you to create wonderful markdown files, which is basically reports which are easy to create, and they are reproducible, and you can include all of your code in it, and then you only need to do is rerun the markdown once you collect more data, for example, and then you can have all of the information that you need. I have included our markdown file in the GitHub connected to this presentation. But it basically works similar to Python notebooks, which I know are a favorite around people who work with Python. It also has an integration with ShinyApps, so you can create a Shiny app directly from our Markdown. It will be able to present it and create an HTML file for it, and you can use it and you can share it with other people. It's integrated with Git and GitHub, so you can work on it and automatically commit and push information into your own GitHub, into your own repositories. One of the good things that is great for teaching is the R bookdown, which is something that we had to learn how to use recently because we had to teach introduction to simple data analysis, which basically creates this type of format where it's basically a bookdown, where you can see all of the information, you can see all of the code, and you can attach fun little highlights for information that you want to know. You can have to show and hide the solution, etc. So this is a great tool for teaching if you ever want to teach anything. And of course, you can create presentations with it. This presentation was, for example, created with R, and you can create R projects where it's basically a container for all of the files that are related. So this was me. I hope that I have somehow managed to convince you that R is great. I think that R is great, and I have not stopped using it since the first time I learned it. Do I use other things in comparison to just R? Yes, I do. I do use a lot of Python because Python, of course, is a development language. It's used we use it for developing experimental paradigms that we test participants on. I use MATLAB for the same reason, or for analyzing additional data. I would probably never use Python, for example, for statistical analysis, however, because I find it a lot harder to use Python for that rather than to use R. And if you do want to know about all of the data and materials that are related to this presentation, I have included them in a little GitHub repository, which has a bunch of other teaching materials about R as well. And that's me.